Alright, hey, Nick here. I am starting a new series of videos that I'll see how far I get, but I, I wanted to do a few videos on the subject of retro computing. This is something that I've been interested in for a long time. I actually did some of this computing, back when this stuff was contemporary in the 70s and such. But recently, it's been an interest of mine since COVID, basically, to recreate some of these older systems and dig into them with a new perspective. Number of years ago, I started building up my own version of what was called an IMSI 8080. It was a Z80 based version, and came up with this, and I've got a whole series of videos on this. It's obviously not the form factor of an IMSI, but it's the same functionality, and that was fun to work with, to brush off some of my old skills and get into some new appreciation for that old hardware. And then I left that project for a while, and recently somebody contacted me and was asking questions about it, and is working on this project themselves, and that kind of got my brain going. And I started poking around and stumbled across a lot of really wonderful resources around some old hardware, in particular the old PDP 1170, which was a fantastic microprocessor. Early to mid 70s, really kind of changed the state of computing. At the time, we called it a mini computer. It was not a mainframe, but it was bigger than what we were calling microcomputers, single chip CPUs. It's a fabulous 16-bit machine, and I found all these great resources, a lot of work that other people have done that just give you these fantastic emulation tools and so on. And it's also possible to buy relatively inexpensively a replica of PDP 1170. So on my Christmas list, I'm actually getting a kit that should let me build up one of these systems, and it's powered by a Raspberry Pi inside, using some of the emulation software I'm going to use in this video series. But this will be, a physical model of the PDP 1170, where you can actually flip the switches, see the lights, and so on and so forth. So I've thought about doing this as a course, and I may do that at some point, do it as a special topics course or something, but for now I just want to kind of share some of my experiences with this system and see where it goes. So I've got an approximate outline in mind for what I'm going to do throughout these videos. This video is just the basic introduction to the concept and the idea of this. The next video is going to work with the front panel and just go through an example of toggling in some simple code, just a basic increment and loop, stepping through it, seeing the results on the front panel display, and just kind of, a bit of a target for where we're going to without a lot of deep, detailed explanation. And then we'll kind of come back to our first principles. We'll look at the PDP 1170 architecture, which is a beautiful architecture. It's what we call an orthogonal instruction set. So there's a set of instructions, there's a set of addressing modes, and there's a set of registers, and you can put those together in almost any combination. And so it's a super fun architecture to work with. Had a lot of really brilliant insights that sort of set the stage for future computer design. So we'll do a video just on the architecture itself, and then we'll dig into the tool chain. We'll be looking at some of these tools that other people have created and made available, including a cross assembler for writing assembly language and assembling it into binary, sticking that on a simulated paper tape, loading it into the simulated PDP, executing it, stepping it through one instruction at a time, breakpoints, all that kind of stuff. So we'll see the whole kind of start to finish tool chain of using the simulated system. Then we'll dig into a little more assembly language programming, including looking at ways we can read the front panel switches and control the front panel lights, and a little more complex code, getting into a bit more of logic and so on, just kind of dig into conditional branches, things like that. And then we'll start working our way out of the box. So we'll play with console I/O. We can run a telnet session to connect to a simulated console and do input and output in that way. There's a simulated paper tape punch, paper tape reader, which we can write to and read from. There's a simulated line printer for making output. All these things work well with, you know, the underlying operating system, so we can create a file that contains the line printer output. We can create a file containing paper tape input and then ingest that under control of an assembly language program, and so on. We'll take a look at interrupts, and there's a beautiful interrupt trap system in the PDP. There's a real-time clock that was driven off of the wall power frequency, so 50 hertz or 60 hertz, and we can use that to generate an interrupt. We'll play around with it, but then those ideas of interrupts, interrupt vectors, and so on extend to if we want to do an I/O operation and be interrupted when it's finished, or when a device is ready for more information, and so on. So we'll do a video on interrupts, and then we'll play with floating point. And when I was using the systems, the people who owned them generally couldn't afford the floating point options, so this was fun to actually do, like, the floating point instructions for adding and multiplying and dividing real numbers, which is cool. And then play with some floppy disk controllers, including how to boot from a floppy drive. And then hop into some operating systems, so some of the old systems from when these PDPs were in use, including RSX11, which was a popular operating system, Ristus-E, which I cut my teeth on, Unix, back when it was Unix, long before Linux, and all of these operating systems, you know, ran well on a PDP-11, and there are ports of these available, so we can actually boot up these systems and kind of see what they do, and then who knows what else to go from there. So that's the basic game plan. No promises, but I'll at least start working on the next video in this series, and we'll see where it goes. So stay tuned if you're interested. Catch you next time.